Oh, we're muted.
You're doing the screening? Yeah. Yeah, okay. So, so that's mine. Just right. So just not that I'm trying to interfere, but yeah, you should be able to get it. But you do have to. Oh yes, I've never done that. Sorry, I can't help. But the other thing is, you probably need the mic as far forward as possible. I know. Yeah, I just yeah. But well, you can get it to beam somehow if you push the buttons correctly. But all you do.
You already won.
Don't touch it, don't touch it, don't touch it, don't touch it, don't touch it.
Yes. I mean, it's good as we're at.
Ready to start? Okay. It's been a really, really interesting week. But thank you very much for coming. Welcome to, I think what is the 11th edition of our kind of conference here in San Francisco. And it's the third edition of COPE, so it's a conference in the US focusing on analytics and the ecosystem as a whole. And we always see, a lot of this happens in the last few months of the year, and I think it's something which is very much reflected in the conference program. And as you'll see in the conference program, it's not so much about Erlang or Elixir. It's about picking your favorite language or actually using these languages together into what has become a big ecosystem. And that's not yet. The motto of the conference is share, learn, and inspire. And this came, I think the motto was inspired itself by a speaker, a delegate who is no longer with us. As we know, Joe passed away last year. But whilst he might no longer be with us, I think his work lives on, and I think these conferences are a reflection of his work. And the only thing I ask him to honor Joe in the next few days, be like him, be inquisitive, go out, learn, ask lots of questions, challenge, and then go out and share, because that's exactly what he used to do whenever he came at these events. Now, we all started off with a program committee, an amazing program committee who was able to put together, I think, one of the most diverse programs I've ever seen in a conference, both in terms of topics and speakers. We've got Miriam, Anna, Fred, Brian, and me, and it's been taken about 6 months to put together the program we've got today, and it's all divided up into themes. I think one of the themes is the beam. We've looked at frameworks, scalability and reliability, web and APIs, tools, introductory talks to both Ireland and Alex here, and case studies. So there are over 50 talks. We have had, I'd say, about 250 people register. Many have not been able to come because of travel bans. I'll get into that in a second. Also worth saying, there's been, in the last week or so, a lot of speakers who've dropped out because of health reasons. They're actually living with people who got reduced immune systems, or they've been put out by travel bans or travel restrictions from their companies. We've replaced every single one of them, and so there's only one talk which is going to be done remotely by Skype, and that's Ingrid Arlington from the OTP team. We felt it was very important to have the OTP team represented here at this conference. And there'll also be a live update from the OTP team as well. That's been recorded, but the person who's recorded will be available to answer questions as well during it. But other than that, please check the app. So if you looked at it yesterday, look at the program again today, because it has changed again. But we've managed to find replacements for all the speakers. Now, this is San Francisco. San Francisco is a very expensive city, and we wouldn't be able to pull off a conference. This conference is very much about community, but we have a lot of companies which are part of this community who are helping us pull off these conferences. And top and foremost, I think we've got the WhatsApp, a huge thank you to WhatsApp. We're continuing to support us as a global sponsor, and it really makes a big difference. There are a lot of delegates from WhatsApp, and I believe we also have a stand outside today. Go speak to them. They are recruiting, and they're doing fun stuff. We've got our platinum sponsor, The Real Real. They've got a team of 80 developers and are growing the Elixir team, so they're going to stand outside as well. Drop by and meet them and learn more about what they do. We've got our diversity sponsors, PepsiCo and the Airline Ecosystem Foundation. And it's what the sponsor is for underrepresented groups in tech to attend. And a lot of private individuals have also made donations. And so what PepsiCo, the foundation, and the private individuals have donated, Airline Solutions has matched, so as to allow basically double the number of things we hand out to increase diversity. And again, next year, I'd love to see your employers up here. We've come a long way, but I think we've got much more work which needs doing. So make sure your employer comes in and becomes a diversity sponsor next year. Also, PepsiCo will be providing refreshments during the break. We've got gold sponsors, so we've got White Source, so a solution for managing open source components. We've got 2600 Hertz, a cloud-based network platform, Airline Solutions, which are your scalability and reliability experts. They all have stands outside. Say hi to them and learn more about what they're doing. Again, I think they're doing really, really interesting things, and you want to get to know them better. Simplify, our silver sponsor. And we've got BTV who are the t-shirt sponsors. And wrapping up, we've got lanyard sponsor, Roma, and our car sponsor, Mux. Now, our shipment from London got stuck in US Customs. I think we had a custom official who was very, very bureaucratic, that they actually wanted to know what the boxes were actually made of. The cardboard boxes were actually made of, and what type of cardboard it was. Yeah, yes, if you see, if you see Gurpreet, yes, she's been teaming with them. They should be arriving very, very soon. So as soon as, we'll be making an announcement on the Wove app as soon as they do come in, and that's when you can come in and pick up lanyards, delegate tags, and the likes. Right. There's a code of conduct. It's we're proud to provide a safe space for everyone. So please follow the code of conduct. Make yourself familiar with it if you've not read it. And if anyone's having an issue, please contact a member of staff. We are the ones wearing the black T-shirts, which says hosting team on them. And also, we'll have rainbow lanyards as well. So it'll be easy to pick and find. We also have, for those of you who have not done it yet, please download the Wove app, and we'll be making announcements. You've got the program, you've got floor plans, you've got the ability to contact other delegates. There's a lot going on the app itself. And we have an access code. Once you've downloaded it, you'll find the conference code and just type in "beam me up." And the most active users on the app will win a movie poster. It's a threat, I promise, and signed by Mike, Bjarne, and Robert. So so they're the creators, and stars of your Canada movie. If you've not seen it on YouTube, that's one to look at. This is the floor layout. So we are in OK Beamer. Right now, this is the OK Beamer room. Gen X is next door, but you need to go out along the corridor here to get in there. And Millennials is also in the back here. So there's a corridor, reach as well. It's really easy to find. There will be signs as soon as you get in there. Yeah, the signs are already there. Thank you. Okay, so that's. Now, in case of an emergency, please make sure where your closest fire doors are and exits. And the assembly point is the courtyard right in front of World Market and Ross, located in Road Point Street and Taylor Street. So if you do hear a fire alarm, don't start looking around and looking at what other people are doing. Just head straight to the exit and get out. So here's a tweet from 2009 when we first ran the conference. Back then, it was in April down in Palo Alto. And, the coronavirus kind of gave us a sense of deja vu. It was, back in 2009, I think, it was the swine flu outbreak. And, this is a tweet from one of the delegates. You might recognize him. Health advice. Right now, be mindful and stay safe. We've managed, wash your hands regularly. That's how you catch the coronavirus. So wash your hands. We managed to get all the which I understand is a married here in San Francisco. We actually took 4 hours online on finding the company which would be able to ship. So please pick it up. That came locally, so that was not something custom. So pick it up. Lots of it. And David sorry, school doesn't just have shaking hands is another way to contaminate. So if the dishes are well done, cough or sneeze, use the dishes and throw them in a trash. And I know if you're French, Italian, Spanish, or Argentinian, please notice another conference delegates. Just at least until the scare is over. And stay connected. Be very loud on Twitter, be very loud on social media. use the code BMSF hashtag. Wi-Fi is a higher space meeting, so that's what you need to use. There's another one which is higher underscore meeting, that won't work. So yeah, use the one with the space. They've set it up for us. And the past use is Beam Spirit as well. And talking about the coronavirus, I think many were not allowed to come. We've decided to go in and stream events from the main room. We had to put it off at the last minute. It was very, very improvised. As and when you get an email saying our team is not allowed to come and so on. So at least they've got a chance of doing it. But the link is shared on the WOBA app. Feel free. It's an open link, so anyone can actually join in and look at the streaming. Tell your friends, colleagues, and anyone else who you think might be interested. And a lot of hard work is going into the talks. The speakers have spent a lot of time doing it, and many of them want feedback. So please vote, on the talks on the WOBA app. If you're not happy with the talk, provide constructive feedback and why it is. Also, speakers have to opt out. They don't want the feedback. So it's your emails have gone out to speakers in that regard, but speak to your past hosts, and they will go in and announce it when that's the case. So and also after the conference, SurveyMonkey, there'll be an evaluation form coming up. Please fill it in. You can win free tickets for other events, and this very event next year as well. So a lot of the feedback which comes through SurveyMonkey and through that gets implemented. So what we have today, the format, the talks, the themes have come from you. So keep that coming. And again, this conference is very much about the talks, but it's also very, very much about the choreography. So there'll be lots and lots of networking opportunities both today and tomorrow. But 2 coffee breaks today, and we've got also lunch between 12:45 and 1:45. And PepsiCo will be providing refreshments during these breaks. And for the evening party, Mux has sponsored it. They'll be providing drinks and nibbles, and they'll be available after the last talk at 6 p.m. And also in conjunction with the last talks at 6 p.m., we'll be having lightning talks in the main room. So for lightning talks, please sign up at registration if you have lightning talks and something you want to talk about. But please do so after lunch, once delegate bags have arrived and been handed out. There'll be a bit of So it's time to pass it on to Brookings Rebecca, who's our keynote speaker. It's not every day you find someone who's kind of like-minded, and I think one of the things which we really believe in is that a lot of the problems we're solving today have already been solved in the past. And by looking at history, we can better understand the future and how to address the future. And what Brooke is going to talk about is how kind of old ideas and paradigms can actually be reused today as the ecosystem is evolving and coming to the next level. So let's hear it from Brooklyn. Okay, slight change of plans. We're going to start with an update from the Elixir core team. Whilst we Okay.
Sorry, my laptop called. We tested it.
Yeah, of course. Did you test it? Never press that button. For work is gold. Okay. Once we reboot the laptop, yeah. We will start with the update from the Elixir 14. So let's hear it. Well, from. Okay, over to you. Thanks.
Hello, everybody. I'm Michał, and I'm a former member of the Elixir core team. But I'm giving this update to you because I was supposed to be the closest thing to the actual member of the Elixir core team, but Eric actually decided to come. But you're stuck with me. You can stay here 2 minutes. So yes, what we're going to talk about today is Elixir, touch on the new things introduced in Elixir 1.9, 1.10. I mentioned some future plans, but also maybe you've seen I mentioned in slides not only Elixir core team update, but also Elixir core and ecosystem update. Likely include some updates from some community projects. Last couple of days, I reached out to members of various people working on various other projects and got some updates from them that I'll be sharing as well. So Elixir 1.9. Elixir is on a 6 months release schedule, releasing usually around June and around January. So 1.9 was released last year in summer and introduced a couple big features, most notably releases and related configuration changes, but also some improvements to the logger, in particular how it deals with overload scenarios, though this is mostly obsolete by 1.10, so I'll just keep that part, and also improvements in calendar types. So Elixir first introduced calendar types like date, time, and night date time in 1.3, when it was deemed that the community didn't handle this part well. And since they were included in standard library, with each release we were getting more and more functions. The biggest change was in 1.8 when we got built-in time zone database support. But 1.9 also introduces a slew of useful functions around this area. Okay, so what are the releases? So releases, if you don't know, releases are kind of a self-contained directory that you can use for deployment. It includes everything, starting with your application, all the code for it, all the dependencies, all the standard libraries that you need, the whole Erlang virtual machine and its runtime, so kind of everything together that you can take as a whole and put on a machine and run. And with Elixir 1.9, it's extremely easy to use them. Once you create a new project with Elixir New, just a matter of running Elixir release, and you have it. What it provides is a standardized way to manage the lifecycle of your application. So there's a command line tool created that you can use to start, restart, or stop your application. You can also issue RPC requests. So while the system is running, you can issue commands to it to evaluate something. You can also use eval, which starts a new instance to run the commands, useful, for example, for running migrations. But you can also connect remotely to the running release and do some interactive debugging, some interactive work while it's executing. So that part is extremely useful. It also includes some tools for running kind of the standard daemon setup on Unix machines, and also install, which installs the release as a Windows service on Windows. So why would you want to use releases, right? Other than the fact that it's kind of, it creates self-contained bundle of everything you might want. It also has some other advantages. One is code preloading. So Erlang VM can run in two modes. One which is called interactive mode, which is the default. Whenever a module is called and is not found right now, the code server will look through the code path trying to find the module and load it when it's needed. But you can also run the VM in embedded mode, which requires you to load all the module, all the code up front. And this is one is used by releases. What this gives you is that when you load the code interactively, it might be that a couple of first requests you get to your service will have increased latency because of this code loading, right? So having all of this done up front means you have more predictable performance. There's also standardized way to do configuration and customization that I'll mention next. And as I mentioned, it's self-contained, and you can also, if you have multiple applications in an umbrella setup or Poncho, in Nerves, you can slice applications to multiple releases with subsets of the systems to have them run on different hosts in different way. So yes, so configuration. So configuration story with Elixir is extremely long and windy. But the standard way of doing it, which is the config.exs module, still exists, but it was more specified more that this is compile time configuration for application. And alongside of that, there was a new tool introduced, which is config releases EXS, which allows you to configure your release when it needs to do dynamic startup configuration. Releases also introduce support for VMRs that allow you to specify in a kind of unified way flags for the virtual machine, like various options for garbage collection or memory allocators or some kernel services, as well as configure the system environment on Unix systems and on Windows. So yeah, that was mostly what I wanted to talk about 1.9, because 1.10 is a much bigger release. It was released recently, in January this year. And every time there's this talk about Elixir update, there's those stats shown. So by this, I verified those numbers again this morning. So Elixir 1.10 is over 900 contributors, and there's over 10,000 packages on Hex that were downloaded over 1 billion times. So almost one download for every 2 users of WhatsApp. But by this time, Hex is not only Elixir, right? It's something we all use in the Beam community. It's great to see growing steadily. So what features that Elixir 1.10 introduce? Most important thing that kind of other things fall off from it is that it requires OTP21, drop support for OTP20, but this allows to integrate with the new OTP logger that was introduced in OTP21, as well as leverage some other things that were implemented in there. But as about the logger part, this was a huge change, and basically by now the Elixir logger and the OTP logger are one and the same. They are different APIs for the same system. The integration right now is still in 1.10 is still relatively shallow. So while you have the same metadata, the same log level, the same messages, the APIs are still different. Elixir 1.11 will unify those APIs a bit more. Easier sorting, which I'll mention a bit more in depth next, and the two guard functions, or guard macros, is struct and is map key. So you can actually use the structure maps in guards now. This is based this is based actually on something I implemented in OTP 21, though with some bugs, and the OTP team had to come and actually fix it. They know what they're doing, I'm not necessarily. But yeah, this is a great addition that allows for much more expressive APIs, and you can, especially struct has a lot of expressivity, in my opinion. And yes, again, releases where there was a bit of work done on the releases. So there's additional restrictions and additional work on compile time configuration. So now whenever you use configuration and compile time, there's some additional verification going on that you actually, this is doing what you expected and not changing it at runtime and then being surprised when it's not actually applied. While it was read at compile time and kind of frozen in code. And there's also a built-in tar step for releases that allows you to build an archive with all the codes instead of just make a directory with everything. But let's talk a bit more about sorting. So this is the standard way to sort a list of elements in Elixir. And it sorts it in increasing order. But what if you wanted to sort it in a decreasing order? Right? So you provide a sorting function. This is kind of readable, right? If you know the idiom, it's kind of easy to see what's going on. But it's a bit harder when you start talking about dates and structs in general, because Elixir sorting and Elixir term order, Erlang term order, is structural and not semantic. So if you, for example, have two dates and try to sort them in increasing order, you might end up with 2020 before 2019, which is not what you want, because it sorts first by the day field, because it comes first alphabetically and not the year. So what you have to do is provide a custom comparison function, which you can see is big, ugly, and lengthy, and not very pleasant to use. So Elixir 1.10 introduced an extended API. So you can provide atoms that tell you which way you want to sort, as well as there's built-in support for this compare function that we used earlier to implement our own comparison. Now you can also module to implement this function, and Elixir understands what to do correctly. And you can sort both ways. This is not available only in the sort functions. This is also available in min, by, max, by, all the functions that compare things work the same way. So yeah, expanding on the configuration, what I touched on earlier. So this is something you might find in the Elixir application, right? So we need to find the database host from the configuration, and we read it from our environment. But we read it at compile time in here. And the problem is that if we later change the configuration and try to start an application without recompiling, it will still use the old value. And that's not what we want. The correct way to do it will be probably to read it at runtime, read a function. But this is a preferred approach, but it's kind of harder to discover it. There's nothing that nudges you towards this goal. So Elixir 1.10 introduced a new function called compilen that you can use to explicitly tell the system that this is a configuration that you read at compile time. And if you later change it at runtime, the boot sequence will warn you saying this value changed since you compile the code. Future versions will deprecate use of getenv at compile time. So we'll be forced to use compilenv into this tracking. Another feature is compiler tracing. So Elixir, so for quite some time now, had this cross-reference database in the compiler, which tracked function calls between modules, reference structures. It was kind of not really exposed to tools. Various tools tried to use it, but it was internal, so it often broke, and it wasn't really good support. So now Elixir has a built-in support for it, when you can kind of plug into the compiler's view of the world. This already provided some improvements in the built-in in the compiler itself, so you can kind of skip some warnings. And there's also allowed to development of, or like easier development of libraries like Boundary from Sasha. So I wanted to mention it briefly. It allows you to kind of declare what parts of your system are allowed to interact with other parts of it. So for example, when you have My System Web module, it's on and namespace, works on namespaces. So My System Web module, for example, is allowed only to interact with My System namespace and only exports the endpoint module. So other namespaces from outside aren't allowed to interact with internals. And this nicely integrates with the compiler. So if you use it, you can get nice warnings, for example, VS Code when using the Elixir language server. There was also some enhancements in the XUnit diffing. So until now, it's used to do diffing between values when you assert it with double equals. But now it also asserts with patterns. So you can sometimes get, and it's especially useful when you have some deep nesting and a huge map, and you kind of don't want to look for 10 minutes which key you misspelled. So yeah, that was Elixir 1.10. Elixir 1.11 is scheduled for June this year. It will introduce another extension to the calendar types, which is strf type or whatever you call this function. So you can print time in a kind of standardized way. There's an is struct with 2 arguments, so you can verify something in the struct, a particular struct. And there's also support for the map.field syntax inside of guards. But there will be support for the syntax. And related to that is kind of deprecation of some syntax, but we'll get to this later. There's a tighter integration with the OTP logger, as I said, and the Elixir compiler will also start tracking boundaries between applications. So similar to the boundary application I showed before, there'll be limited support in the compiler for this. So for example, if you declare application as a dependent, if you don't declare an application as a dependency, you use a module from it, the compiler will warn you. Then when you assemble a release, for example, it won't be available. So we want to be careful with it. So related to this allowing map.field syntax, Elixir has the same syntax for accessing a field in the map and calling a function with no arguments dynamically on the module. And this is a problem with it because the syntax in guards will work in one case but not in the other. So the plan to tackle it is to kind of separate those two through warnings and deprecations. So basically, whenever you call modules, you'll need to include parentheses, and whenever it's a field access on the map, you want to be able to include parentheses. In 2.0, the AST will slightly change to reflect this difference. And yes, with all the logger, there was a lot of work put into it by Lukasz, so I wanted to give it a shout out. And the next iteration will support all levels of OTP logger. That's much more than Elixir. It will support structured logging, so you'll be able to log maps or keywords with some structure instead of just strings. This is useful in some setups. And you'll be able to set log levels per module, so not only globally, which should also be made useful. As far as the community projects are concerned, I wanted to mention Hexdiff, which is a great tool for exploring changes in packages, and you'll be able to hear more about it, I think, after lunch today. There's Lumen, which is a WebAssembly implementation, Beam implementation on top of WebAssembly, or in Rust, but targeting WebAssembly. And there was a lot of progress done with it. There was, as far as I'm aware, there was a progress report last week at Lone Star. So if you're interested in that, when it comes out, you should watch it. There's a great new HTTP client released called Mint, which is based, which doesn't impose a process architecture, but mostly about providing a functional interface, and you can bring your own process architecture to it depending on what you need in your application. The work on the Elixir language server also resumed with a new set of maintainers, and it's been continuing pretty well. The support is really good right now. And there's some more exploration to the configuration space from the community. So like two interesting projects I wanted to mention. I also talked a bit with the Nerves team. So Nerves is an embedded framework for Elixir. The two big changes was the Nerves pack and the VintageNet projects. So Nerves pack is kind of a boot system for Nerves applications that do networking, DNS, SSH access, firmware updates, and all of those stuff. VintageNet allows you to configure a network on your devices very flexibly. The Nerves team will be focusing on documentation. Right now it's in multiple places. So kind of the goal will be to centralize it to make it easy to understand all the different components you have to work with, and also expand the system to work on more devices. There's Broadway, which is the tool for data ingestion and data processing pipelines that was announced last year at this conference. It was only announced with support for SQS, but now it supports Kafka, RabbitMQ, and PubSub. It's growing really well, has a lot of features, and it's really useful in a lot of scenarios when you need to work with those streaming type of services. And yes, I think that's it for me. I think I went a bit over time. So I will yield the microphone to Brooklyn now. Hopefully this time it will work. And thank you.
Let's hear it from Brooklyn.
And I'm not going to try plugging anything else into this, just in case. So, thanks for being patient, and get ready for being the future. Some old ideas maybe. So, given that this is a talk about looking back in a lot of ways, this is the obligatory quote about having to look back in order to move forwards. And one more from Perlis. He has this really lovely list of about 110 epigrams on programming. So many good ideas we never heard from again once they embark in the voyage on semantic health. So let's talk a little bit about this talk. And let's start with why am I up here talking to you? So my name is Brooklyn Zelenka. You can find me on the internet pretty much everywhere as XP. I'm the co-founder and CTO of a company called Fission. We're building the future of web native apps. That's applications that run entirely self-sufficiently in a browser. You can think of this as post-serverless or post-cloud. I heard somebody recently refer to this as blue sky as opposed to cloud because it's a clear sky. And our goal is to make backend and DevOps obsolete, which is going to make me not very popular in this room. But don't worry, this is still pretty heavy R&D stuff, so you're safe for a little bit. I'm a programming language theorist and virtual machine. I used to say enthusiast, but I guess I've actually done work on that now, so virtual machine designer. And most recently, I got to use that work when I was a Ethereum core developer. If you're not familiar with Ethereum, it's the second largest public blockchain. The twist on it versus something like Bitcoin is it's programmable. So really, mainly just doing standards work there. Also just tackle a lot of the virtual machine stuff. I'm from Vancouver, where I founded the Vancouver Functional Programming Meetup and VanBeam. And in this community, I'm mostly known for a couple libraries. There's a suite called Craft. About 5 or 6 libraries that port in a lot of ideas from Haskell and other MLs into Elixir. And like, monads, async map, all of that stuff. And Exceptional, which is an error handling library that lets you do happy path programming and handle your errors at the very end. A little bit like the with keyword, but you don't have to do all the manual threading yourself. So the sort of tagline online for this conference is discover the future of Erlang and Elixir, and we're talking about the past, which seems a little bit strange. So why this topic? I've given a few talks that are based around sort of classic papers. Go-to's considered harmful, or talking about 4th and 5th generation languages. And people come up to me after and say like, oh, that was a really good idea. It's nice that we can apply that now. That applies to something I'm doing today, but I wasn't aware of it until now, right? I've been reinventing the wheel. So is there some way that we can take these old ideas and bring them in as a way to move the rest of it forward? I was just at breakfast this morning chatting with someone who said, it's like the rest of the world now is discovering all the stuff that we've been doing in Erlang for the last 30 years, right? Are there other things that we can take from elsewhere and bring them into our ecosystem too? Selfishly, I want to push these ideas into other people's heads. So this isn't like concrete, here's how to refactor your code today, right? It's just conceptual. I want to push these into other people's heads so that we start having conversations about other ways of doing things in the Beam and how we can evolve the Beam over time, because it's a little bit hard because the Beam does so much right, and sometimes we have to explore around other areas, especially as we get more languages and more paradigms into the system, right? Elixir and Erlang are pretty similar, but there are some less similar languages popping up. Alpaca is an ML, right? LFE is a Lisp. So how are we going to move forward as an ecosystem, cross-language and cross-paradigm, if we don't know what we don't know? We haven't explored the studio space. Right? What if we're stuck in a local maxima, which we certainly are, because when designing things, you're doing a totally blind breadth-first search through your design space. So you end up here, and sometimes you gotta go rummaging around in some less great ideas before you can make your way to the next paradigm. Spoiler warning, the 3 main things that we're going to be talking about are breaking out of linear thinking with the von Neumann architecture, new types of modularity for the Beam, and composable languages. So, in the beginning, this is another epigram. Says it's sometimes difficult to find the correct unit of time to measure progress in programming. Some cathedrals took over a century to complete. Imagine the grandeur and scope of a program that would take that long to create. And really, those end up being the fundamental building blocks we're going to build further things on top of. The Bean and OTP broadly is a project that's been going on since the 80s. Right? That is a long project. Right at the very beginning, we had just hardware, and then machine code and assembly, and we eventually got to higher level languages. The first widely used one was Fortran, which most people would consider low level, but for the time was a very high level language. And to put it in perspective, the main computing interface at the time was the punch card, and people were listening to Elvis' Heartbreak Hotel. 29 years go by, and we get Erlang. Computing now looks more like what we would really consider to be a computer, right? It's the Apple IIc, which was released that year. People listen to Madonna, feels like modern. But it doesn't sound like a long time. 29 years is a good chunk of time. Later that year, I'm born. Just to give you a sense of scale here, right? And that's not to make anybody feel old, which I realize that we're in a room called OK Beamer. But just to give you an idea of the size that we're dealing with here. Here we are, 33, 34 years later, at Coding SF. Most people's computing device is in their pockets. I'm now too old to really be up with the cool stuff, but I'm told that Taylor Swift is very popular. So that's a lot of time, and a lot of stuff has happened in there. The 34-year chunk has had an exponential growth in the industry, the number of people involved, all the people in this room, right? We've explored a bunch of different things. So why are we going to be focusing on this first 29 years, more or less, right? And that is that history sort of propagates itself, right? You don't change, completely all the time. You're just making little changes. So let's think a little bit about paradigms. Douglas Rockford, he's a major figure in the JS community, said it's really difficult to distinguish a new paradigm from a really bad idea because the shiny new object is part of the old paradigm. Right? We never completely shift out of the old thing. It's always just a slight variation. Right? You only have so much novelty budgets in your organization, and that changes depending on which company, right, and which project. But for the most part, people want something that looks somewhat familiar. This is a large part of why Elixir in particular has done so well. It had it felt like Ruby, even though it's very different. And the same goes for things like Docker. We've been building the same style of LAMP architecture, like literally PHP, a database, and a web server, that basic architecture for 20, 25 years. So when we run problems with it, we said we want to do as little as possible to change that. So we created a container to make sure that it'll run the same on the cloud. And we can take complexity and we can move it around, but now it's somebody else's problem. And is this going to be the long-term solution, the 50-year solution to problems of deployment at scale? I don't think so. Right? We're now seeing the shift to serverless, which is we're going to take a container and we're going to shrink it down to a single handler. It's the same slight variation, but just shrunk down. Larry Tesler passed away recently, sadly. The guy invented copy and paste, which is pretty great. He has the law of conservation of complexity. Every application has an inherent amount of complexity that can only be moved around. They're not copy with them. So what are some of the trade-offs that we're making on the that with some other design choices we could change? So looking back through the evolutionary tree of programming languages and paradigms, what are some places that we could make cuts or pretend that there was a different outcome to history? Something else did well. We're going to be looking at 4 array-based languages, the applicative model of programming, the standard ML module system, which is now also in OCaml and recent, and natural and business language. So we're going to start with something totally alien. Does anybody recognize this language?
Yeah.
It's more than I expected, that's great. Yeah, it's APL. Does anybody know what this does? I'll give you a hint. Anyone? Game of Life, yeah, exactly. It's always Game of Life. APL is an array-based language. It does very well with matrices. So unlike, say, object-oriented programming, where the basic unit is the object, functional programming, where the basic unit is a function, everything is based on arrays. This makes it a really nice fit for something where you have a giant grid that you need to go over and look at the neighbors and update. So we can express what is otherwise, like, it's not a massive task, but it's not a one-liner in most languages, very easily and succinctly. What can we learn about the beam from APL? So cellular automata, the game of life, and actors have a similarity, right? We have emergent behavior out of both of them, right? Each step is very, very simple, but reasoning about the whole system can become difficult. Right? When we're doing things with gen servers, we're not looking at the system as a whole, we're looking at an individual call. It's hard to keep the whole thing in your head. You draw little diagrams. Okay? You need to run a VM in your head to reason at that level. Right? You have to have the simulation going. And we can abstract some of this away, right? And we're starting to do that now. We have Broadway, we have constant arrows in other languages. But the trade-offs are very different. You don't have the granular control. The thing that makes APL work really well for this kind of thing is they have a succinct language for it, and by default, not everything, but by default, everything is parallelizable because it's an array. It's just collections. The universal scaling law. So most people are familiar with Amdahl's law, which says, as you increase parallelization, you get to diminishing returns. Universal scaling law says if there is a point of contention, some shared state that everyone needs to go and talk to, it actually drops back off because you have a coordination cost suddenly. It's worse than having less parallelism, depending on the type of problem you're trying to solve. So can we get automatic parallelism in Elixir or Erlang? Absolutely we can. Witchcraft has this. So we have an async map. It's a lot like enum map, but takes everything and just automatically shoves it into a task. And gives you back the same result in the same order because it's essentially enum.map with some extra properties on it. And we get a performance speed up, right? So something that's going to take, this is just stand in for a long running process or a 500 millisecond process, but we can do 10,000 of them in a second. This works because we have a shared nothing architecture. We just have a collection. This is great for embarrassingly parallel problems. And we can do a lot more with macros in this as well. We can do analysis ahead of time of what we're going to be operating on. Is it a short list? Is it a long list? Do we need to have pre and post conditions? Do I, because something happened earlier in the code, need to check that something's available? No, I just know that it's. So we can start pulling these things out. Once we have arrays, we can have tables. Table-oriented programming, or TOP, just happens to have the same letters as OTP, was fairly popular for a while. It's the reason why Excel is so popular. VisiCalc sold a bunch of computers, which is sort of the predecessor to Excel. It was a killer application in, say, the late 80s, early 90s. And we do use tables. We just don't think about them that way. So here's a naive implementation. We have a user, fields on it. There's a table with the same data, and then we just have a list of that. You can see the fields as columns in the rows. But now that we have this idea that, wait, I'm working with tables in memory, we can do all kinds of stuff, right? We can work with this in parallel, the iterative rows. We can work with all of the name fields at once, right? We're now in a two-dimensional space. So if I have data, like so, and I have functions as well, why can't I also map multiple functions over them in parallel? The actual functions in parallel too, as well as parallel data. Right? And we can do this because again, we've changed the restriction system. We're saying that there's no contention between them. So again, using Witchcraft as an example, we have provide as a function. So you give it a list of functions, and then you provide it a first and a second argument. And this is going to take all of the first values and first provide as the first argument, and then provide in the second argument, and give you back all of the combinations of those, fully in parallel. While we're thinking about tables, then, and now we have tables in our program, that means that we can take Ecto and put it everywhere. Relational algebra is super powerful. It's very well defined. We understand how it works. There's a reason that databases do so well. What if we took those same things and applied them in a higher level language to everything dealing with data? We would get potentially massive speed ups. We're not dealing in the small anymore. We're now dealing in the large. Let's talk about composition. We're functional programmers, right? We know about composition and modularity. These are all about symmetry, really, right? And breaking things apart into different dimensions. So symmetry is a complexity reducing concept. See it everywhere. And you can't communicate complexity, only your awareness of it. So what exactly do we mean by composable? Right? The name has no concept of composition, we just have application. Functions are a way of talking about not just transformations of data, but it's almost like a piece of data with a hole in it that you're going to finish, right? But it's still, an application is that filling. There's the destruction of this abstraction. So what kind of composition do we have? Well, obviously we have function composition, also higher order functions. Those are both kinds of modularity. And then we have rules, like commutativity. And all of these together are kinds of orthogonality, right? So just like when we have a vertical and horizontal component to space, and then with the two, we can think of them separately, but we put the two together and compose them to get a much more powerful thing in two-dimensional space. We can rearrange concepts by using these. So we have composition in the data dimension, which is data structures, structs, lists, all of that. We have composition in the function dimension, which is what we end up talking about a lot in functional programming. And we can extend that slightly and then have data flow as well, do parallel composition. We can compose capabilities with higher order functions and also protocols. And we have orthogonality of execution as well. So because we're dealing in concurrency a lot, we start thinking about how things are executing and the rules between them, right? So this blue dot, over time, happens at some point between those two lines, and we don't really care when. And we can move around exactly when it happens in sequence, right? It doesn't really matter. Right? That's not one of our assumptions in the system. So we can take a totally parallel system and test it completely sequentially, debug it completely sequentially, and it'll still work. And we can even plug these in together like so. So here's a diagram of how data flow can happen, and then laying that out as a function, right? Fairly standard data flow stuff. So we can do all of this in Elixir today. That's great. My question is, how modular are our modules, okay? and libraries for that matter? Right? They're really namespaces. They're just bags of functions, and maybe a data structure or two. Libraries, everything's hard-coded as dependencies in libraries. If you want to swap out a dependency, you need to fork the entire thing. Right? That's not great. Or you can encode it directly in there that it's going to call out to another. There'll be some runtime instantiation. Right? It will call out. We can get module-level modularity with higher-order modules. So this is a simple example from a real-world use case. So a few years ago, I was working at an agency, and another team, subcontractors, had never seen Phoenix before, never used Elixir before, and we're building an app, and the deadline was coming, and it was just the app was just not in a really good place. So handed it over, and we said, okay, well, we have about 10 days to get a working version of this. What's the fastest way that we can work and make it flexible? So we wrote a Phoenix vertical, which did a whole stack, right? Router, views, control, the whole thing, with the ability to override individual pieces using macro, right? And the ability to plug in other dependencies into it. So here's a def module with more arguments, where you can now pass in other dependencies, and we're giving it default dependencies as well, right? So for queries, we're going to have an ecto query. For the schema, we're going to use ecto schema. JSON's always, right? This means that it needs type as well. So type our module, the interface to our module, because it's a function from modules to modules. And then into the module as well. We started calling these hot dependencies, but this is an idea that's existed for about 35 or 40 years. So just like we have hot code, now you don't have to do everything all the time, right? We have modularity in our libraries. It's really not that hard to do this kind of thing. So in one of the Witchcraft dependencies, or part of that project, is one called type class, which gives you protocols that can depend on each other. All check class compile time enforced. It won't compile if some piece of data doesn't have a protocol implemented on it that you say it needs. And it's about that dependency piece is about 60 lines of code. The entire library is maybe 500. Right? This is pretty straightforward to do. We don't need to change the compiler, nothing. It just this is the nice thing about having an extensible language, right? We have macros, we can send the language, and these things work really well. Those types I was mentioning before are essentially behaviors. We don't care about everything in the module, we just care about the pieces that we need. So behaviors actually end up with another set, right? A compile time use instead of just a runtime one. And finally, declarative embedded DSLs. highest goal of programming language is to enable good ideas to be elegantly expressed. Right? Not be stuck in the muck and in all of the details all the time. So domain-specific languages, we're familiar with them, right? Ecto's one. We use them. Some people say, well, you know, everything's a domain-specific language, right? Assembly is a DSL for coding computers. Right? And I would say that there's a spectrum, right? There's no like exact delineation, but it's roughly between a language and a framework, right? It's something that has something to say as opposed to a toolbox of pieces. So, you know, using some operators, this is not a DSL, right? This is just library functions. This is just Elixir, right? But this starts to be a DSL. So this is LG. It's a data builder, both on the Beam. It generates for you a bunch of things, including default constructors, default arguments, the type, runtime checks for conditions, and you can override things like saying, you know, I want the numbers to be, you know, 1, 2, 3, 0, 1, 2. It actually really ends up being quite a nice fit for a lot of problems, like, you know, in this case, a video game, right? We're going to have a just describe the player character and the things that it can do, and we've now created a smaller version of the design space, right? It's not all the nitty-gritty details. So how do we make this apply to business problems? What can we learn from that space? What can we learn from the dreaded COBOL? So for those unfamiliar, COBOL, Common Business Language, was used from the sort of, I guess, the 50s onwards, and has a verbose syntax, which we'll look at that in a moment. And used in a lot of banks and places like that, and is still running today. And if you write COBOL, there is a good chance that you can get a big salary from going to these places and writing code because nobody wants. So, and it looks a whole lot like this. A lot of commands are multiple words. It's trying to kind of read like English. The big advantage here is that it's readable by non-coders. Right? You can get a general sense of what's going on. It's pretty straightforward. The complexity is it's not very good at handling large complex systems, but it's very readable. So a few years ago, I was at a security token exchange. They brought me in to write a formally verified language for doing blockchain-based stocks and bonds trading cross-border. Our constraints were it had to be readable by vendors, and it had to be formally verified at compile time. It had to be able to take things like the VC Securities Commission, the CREA Exchange, and the SEC rules and apply them in code, and check that the code we're writing follows the rules, because nobody wants to go to jail. And we ended up with this unholy union of COBOL and Prolog that worked out actually surprisingly well, right? You can just write these things, and it has an algebra that it checks, and it's very well defined, very clear what's going to happen. And not only can a lawyer read this, but the business folks were able to write this. Ben Church gave a talk in Elixir, in Big Elixir earlier this year, where he wrote a DSL, an external DSL, where business people were writing business logic for doing scheduling at veterinarian clinics. Right? It was a small language, and really just inequalities, things like that, right? But my gut reaction was, wouldn't they be afraid to do that? Programming is a scary thing. And no, they were perfectly happy to go in there and be like, oh, I don't have to wait a week for this change to happen. I can just change this. Oh, great, fantastic. And they felt empowered by it. So this kind of thing is really great for doing domain-driven design, right? We can communicate with domain experts. We can make sure that they follow certain rules so that they are correct in construction. So if you can't express something that doesn't work, we can check them at compile time. Or at runtime, right? You can have pre and post conditions there. And the big major advantage of this is it's a language that exactly fits your needs, no more, no less. No extraneous detail, and you don't need to extend it, and you can snap them together, right? Most of the ones that you see today are very inflexible, right? Ecto just kind of does Ecto things, right? It talks to a database, and that's sort of it. You can't work with it on or I guess you could write a backend for it, but it's not really meant to work on other kinds of collections or be interlinked with other kinds of code. It's really meant for talking to a data store that lives sort of there somewhere. And this is called a shallow embedding. It's the quick and dirty way of doing the DSL. Okay. You just use the built-in AST. What it can represent is limited, or it's just some functions that provide a really nice subset of the language, but that they just run immediately, right? There's zero interaction between that and actually running it, right? So the algae example I gave earlier is just a shallow embedding, right? We get this nice syntax on the far right, and then that just turns directly into structs, right? There's no in between. But remember the structure of these structs for a few slides here. Deep embeddings are like a better AST. They come in 3 steps. You build a game plan, you optionally analyze and transform it, and then you tear it down. And you can tear it down in sequence, which is where the compositionality comes in. So building up a plan, so this is for doing those parallel pipes from earlier. It doesn't necessarily have to be structs, but because in this case we're doing so much of this at compile time, the runtime overhead doesn't really matter, and it's just easier to follow. So splitting and unsplitting in a declarative way, right? And we can make that read a little bit better by putting syntax on it, with some do's, and each line here is now going to be split, and then we're going to join them at the end. But that just generates this, right? Nothing else. And then we can take that and we can interpret it, right? So we can write our own AST now. We don't have to rely on the Elixir or the Beam AST, Beam bytecode at all, right? It's way more powerful. It's fully in your control. Using logic as data, so having this done in a data structure is much easier to look at and check than testing a bunch of functions, right? We can just look at it and say, like, is there an instruction in here that says to do this thing? Yes, great. We can test the thing that's going to transform it into actual running code separately, right? We have this modularity, this orthogonality again. You can do things like time travel debugging, right? You can keep that AST around as you execute and check when that went wrong, where was I in this, not stack trace, but in this data structure that's designed for what I'm doing. And I can even get it back into the next syntax again. And the final one is unlike protocols, where you have a single canonical implementation, right? So we have one enum implementation for a list. We have one enum implementation for anything. You can pass these in as you need, right? Because it's just an interpreter. So here's a little a DSL composed out of several others, right? So you have a little dog, it's going to move around, and we're going to print some messages. And we have several languages. We have movement, we have time, we have printing, and setting the ANSI terminal. Again, you can do the AST as a series of nested structs like that. And that's generally my go-to for this, but because in this case, it's just a single linear straight line program, we can think of this as being just a list, so we'll do that for simplicity's sake. So we just have, now a bunch of different records in the list, pretty straightforward. And the interpretation on this feels a lot like GenServer, right? We're going to handle text, and if we get something that we match that we understand, then we drop down to that one and execute it, right? Or at least place in the function that would if this is having compile time with the macro. And we do this again and again for the different DSLs that we compose it. So handle gameplay, handle movements, right? Handle the ANSI true. And then you build an interpreter out of it in sequence, in whatever order you want them to get evaluated in. And it's pretty straightforward, right? It has the same layout as GenServer, right? We have a command, and we have an agent that's going to hold our states, and we're just going to pass them through. And now we can take this, add one more line, and it all just works. Which means now we can take libraries that ship just mini languages, not even necessarily the implementation, but just well-defined, structured ways of working, right? Movements, text, all of that, in a way that is trivial to mock, really easy to analyze, and that we can take and even say, I'm going to take these two, and I want an interpreter that does certain things based on if a command came before it. Right? We can get really, really a lot of power here. Which brings me to, finally, making some new mistakes. 5 problems for the next 30 years of Beam. Hopefully more like 10, but we'll see. First one's a freebie. We need WASM support. This is already underway, but we need client and edge Beam. If we're going to survive and stay relevant, really. We need to lower the barrier to entry, right? Low code. DSLs, business people can write, right? Why are we the keepers of the technology, right? With this wall. The more people that can code, the better. Right? It's the most powerful tool we've ever invented. We need better practice tools. So there's a lot of people that are really excited about types these days. Types are one kind of static analysis. Dynamic analysis, also very important, and other kinds of formal methods. Automatic, dynamic, parallel evaluation. So determining at runtime whether or not something should be run sequentially or in parallel or concurrently. Again, getting out of the individual details. And finally, mobile agents. Right? This is actually the DSLs work very nicely with this too, where you get partway through some computation and then you can ship it somewhere else and continue the execution. So instead of always putting data next to compute, we can put compute next to data. And one final parting thoughts, which is another epigram. Dealing with failure is easy, work hard to improve. Success is also easy to handle. You solved the wrong problem. So work hard to improve. Thank you.
Okay, so we don't have time for questions. Let's have a break and we'll start again we're moving forward the schedule by 5 minutes at 1:45 in their respective tracks. Thank you, Brooklyn. Thanks.
Okay, so my name is Manuel. I'm working in Airline Solutions as a Dutch leading student from the here. But I'm here today to talk about PHP. It's very weird to talk about PHP in airline and sales conference. I'm making usually that kind of word experiments and word projects. I did also the implementation of a MySQL server for Beam to ask to using SQL queries instead of HTTP REST APIs. I thought that well, maybe MySQL is more fitable to access to data than the HTTP JSON. But well, in this case, I was implementing PHP on top of Erlang because I thought that in the terms that where we started to work, most of the people were using PHP, and I was considering that Beam has a lot of features that could be shared for PHP developers. So starting, this is going to be like a journey, and I'm going to try to explain what is actually PHP because most of the people are hating it and they are considering that it's only a language, and it's well, most of the people consider that it's not a language itself, and more or less it's true from the beginning, but that was changing through the time. And I'm going to try to explain why I was trying to implement the PHP on top of Beam, and finally explain how it's working the project I create, that is ePHP. Well, I was not thinking about the complicated names. It's plain simple, Erlang and PHP in the name. So starting. What is PHP? So PHP is a language with a accepted syntax. That is because it's following the C and Java syntax. So most of the people are comfortable using that kind of languages. It's easy to understand for most of the people that came from that specific world. And they use arrays for everything. There is not another type of data when we are out of the integers and strings. And it has a lot of examples these days. You can see the logos there, and I'm pretty sure that you can only checking the logos, you have more or less the names of which projects are there. So for example, WordPress, PrestaShop, and Moodle, there is a lot. And if you check, not the most famous language, which languages are running the servers in internet, you can see that these days, because I copied this from yesterday, is more than 75% of servers in internet running PHP at this moment. So PHP is very in use. So, well, when all the people start with the typical example of PHP, is saying, well, the hello world is something like a print hello world, and you are done. I was attending a conference from Rasmus Lerdorf, that was the creator of PHP, and he said, well, the first piece of code is not correct because PHP is a template language, it's a markup language. And even if you write the piece of code, it's not correct because PHP is a template language, it's a markup language. And even if you write the second part, only the text of hello world, you pass that to PHP and it's printing hello world. So it's correct to say that the second example is a valid PHP code and it's printing hello world. So I think from all the languages that you can find out there, this is the most simple language because it's detecting what is text and using it as is. And of course, as I say, PHP is a template language, so it's intended to be used to transforming text. Another example, a bit more complicated, if you see the right part, that is the structural HTML page, you can see that is the HTML typical page that has a page that is extract for a table. But you can detect that is the HTML and is injecting some specific code like for each and some specific tags that is putting some specific data inside of the attributes and the content. In the left hand, there is an array that is specifying the information that is going to be used for each. This kind of program is usually what was developed from the very beginning. What was intended the way to work usually with PHP. So you can develop some specific pages. You have a set of pages in the server, and when the server is accessing those pages, the information inside is translated only when you find a tag. That is because, for example, the left part is starting with the open a tag. If you are not opening the tag, that is considered like text and is not running anything. So the structure internally of a PHP system is architecture that you can find when you are using PHP. It has when you are running a specific request in the server, you have specifically the part of in red. You can find the streams that are specific data that you can get from outside to get into your program. You have the output that is linked to the errors usually, and the configuration you can access to get the general information that is configured for PHP. In the blue side, you have the specific part of the storage for the variables, the classes, objects, includes, functions, and constants. That is specifically the architecture that is configured when you are running PHP. So something that you can do with PHP, this is a real example I was using in the production. It's 20 lines and it's a gateway to translate something coming like a request using JSON for a HTTP. It's creating a swap client to another server, completely different, putting the information that is received by JSON. And then there is returning something that is putting in result, and the result is putting the output within the code for who was coding. So this gateway is completely functional. It's to access to a server that was only talking in SOAP, and there is only 20 lines. So, well, and now Vim. Why PHP? In terms of why I was using PHP on top of Vim is because, well, I came from Spain, and all the countries are completely different using the languages and the technologies. And Spain and the telco companies are very weird, I have to say. And they are using all the time PHP and the voice XML and the connections with asterisk, free switch. And they consider that using PHP to generate voice XML pages for the systems of telco was very easy, and they had a lot of people to hire because PHP is very famous, or there are a lot of people that prefer to learn how is working PHP in preference to other languages. So that is because even in telco companies they use PHP. But of course, there's a lot of issues because the systems are not really, for example, PHP has not the possibility to run some specific process in background or do other things that that is very common also in other languages like Python or Ruby. When you are running some specific servers like web servers, usually that is triggering a request, is attending the request and then die. And the problem with this is some of the application they were creating was related to queues of management of calls. So the queuing of the information and the return of the information to being used for the next call was very important. So as I say, the PHP technology is very limited. There is no concurrency control. There is single thread. There is no possibility to create another process. This, of course, not real time. And even the PHP is time limited. You are running for more than the limitation time that is configured, that is stopping. It's limited by the operating system. You can only run the number of processes that are configured or led by the operating system for that specific application. WebSocket, they say, well, what's that? It's not possible to use them with PHP. So, well, PHP has a great flexibility. As I say, it is possible to create great programs and flexible programs in only 20 lines, but with great flexibility comes great responsibility. I think PHP is the language that more vulnerabilities has these days also. It's not the most used, but also the most vulnerable. And the most difficult issue that is appearing these days is cross-site scripting, but also file uploading. Because as I said, when you put some PHP file in your server, that is running by your server. So if you are uploading a file and that is reachable by the web server, you are being able to run whatever that is uploaded to the server. So that is because WordPress sometimes is so buggy. Well, the people can say, well, but even if you have to, if it's easy to learn, when we are talking about to use Erlang, for example, or Elixir instead of PHP, if we are going to jump into OTP, isn't easier like the proper language. And well, Elixir more or less is similar to Ruby, and that could be accepted. But Erlang is not, so it's weird. All the people that is starting to use Erlang says that is so weird. And there are no working code. In Erlang, it's usual that you are searching for websites. You are only being able to find Sotonic. That is the only CMS that is already available these days. And it's not very common to see companies putting Sotonic as their CMS. It's more frequent that you see the people come to WordPress and put it fast, and that's all. And most of the companies think that, well, if we put some workaround like Redis, RabbitMQ, and everything like runs and a lot of stuff around PHP, it's not needed to change. So we can live with the workarounds. And other things, they need to be simpler, flexible, and have more examples. So that is because I was thinking about, well, if we brought PHP to Vim, so I was creating ePHP. In the architecture of PHP, every part that is related to those circles, I was creating one module that is inside of the ePHP, and well, this is built in Erlang. So that is because they are ePHP underscore and the name of the cycle. So you have a variable, the creation of different streams, for example, the handle of the output, the configuration, the handle of errors, the use of constants, the definition of functions, the inclusions, objects, classes, and variables. Of course, most of the things that are in PHP, like objects, classes, and even the mutability, that is not being able in the Erlang. I had to interpret that behavior, so this is not compiling to Beam, that is interpreted. And the phase to make this action is we have the ePHP parser. This is split in different files because I try to use Lex and Flex files, the lexers that are available usually, but the PHP syntax is weird. So it's not being able to fit inside of that, and I had to write by myself the parsers in Erlang. So you can find the parsers under the ePHP underscore parser underscore, and depends on what is parsing. That is the file that is in charge. So that generates the compiled tuples and records that is going to be in user for the interpreter. That is the PHP underscore interpret and ePHP underscore context. So an example, in the left part, you can see a PHP code, and the right hand is a parser code. That is when we apply the parsers, that is generating that specific representation that is going to be in use for the interpreter. A bit more nicer using the records, but wider because it's printing the name of the fields. It's like that. And well, I created this with the idea to be extensible. So if you create, you put the ePHP like a dependency in your project, and you create a specific module that has the behavior of PHP lib, implementing those functions, that is the definition of the what kind of information you are providing to ePHP. You can define more functions inside of ePHP, and configurations, constants, the handle of errors, and even classes inside of the system. So an example from the PHP lib that is in charge of the strings. You can see the first line, for example, is in array. That is a function available inside of PHP. That is getting two arguments as minimum, three arguments as maximum. Is returning undefined if it happens some error, and is checking the input, like the first element should be a mixer. That is the way PHP is calling to whatever, or turn of any error. The second should be an array, and the third is optional value, that is boolean, but the default is false. So you can define all the specific functions you want to plug, and then define the specific function like this. That in this case is checking if that value is inside of the array. So it's only use a member in this case, and checking that that information is available or not. So it's only one line. And most of the functions, like the math functions and others, is very easy to implement. So as an example, in the project Grapeful, that I call that for the project don't be called the PHP, I use another name. I created three different repositories that are implementing JSON, MySQL, and XML. And in the left part, you can see the default libraries that are available inside of PHP by default. because one of the things that PHP has that I think not most of the languages has, that is the huge number of functions that they have is awesome. You can go to the document of PHP and find, well, I want to do something with the strings. You find generally, and I'm pretty sure that they are a function specifically to do that. So checking of course, I didn't implement 100% of all of them, but strings, for example, and the file, I think, they have most of the implementation of the functions, and the others, well, are still pending. And as an example, I wrote a long time ago, this was in 2018, an example that I was working with the XMPP. The XMPP is a protocol that is used in people like WhatsApp to communicate people at the beginning, that you can communicate also machines. So the idea was plugged inside of the network of XMPP some component, and when you are connecting like a client, you ask something to that component, and that is behaving like a bot or responding to something. The idea was create that component, putting ePHP as the base of to create specifically what I want to create regarding the bot, and create specific functions to send and receive the messages from XMPP. The structure of the example, for example, this is what we are receiving using the standard request for PHP. We are receiving the whole specific XML, the stanza, something like that. And we are responding exactly the same. It's an echo bot. So you see the snatch send binary and a snatch message. That are the two functions that you can see here. They are created in Erlang, and they are published in the way of we can use them from PHP. So that are providing us a small set of functions that we can use, and the specific function that we need for our tools. In this case, is getting the message, that is putting the request, performing some change. We can access to another system externally, and then provide an answer that is sending by the function snatch send binary. And the snatch message is a proper function to create the XML and not depend on something inside of PHP. So this is published in Medium. I think it's easier to find. I can send you the URL if you want. This is in the Snatch XMPP. Snatch XMPP is a set of libraries in Erlang to connect using components for XMPP. I published there the Snatch PHP. That is the extension to put with Snatch and take advantage to use them together. So you can see there are only 3 files in the project, in the source code. The first one is the libraries that are in use inside of PHP, and the others are specifically the function that we need for the application. Another implementation was for Phoenix Framework. Proof that it's possible to use it also with Elixir, and it's publishing Hex. It's ePHP template. You can plug in your Phoenix application, and then they use templates that instead of .html .eex, and you change that for PHP, and then you can use PHP instead of EEX. This is very useful. You want to provide some specific other different language to your designers. If you have different people in the company and the designers have no idea of EEX and they want to try what they are designing in the typical LAMP stacks that they have. I was implementing this because I was in that situation and I was saying, well, better instead of explaining EEX to designers, I prefer to put PHP in my project. So as you can see, we can use even include ones, so the code can be split in different files. And well, the output is what is provided by the date, the function by PHP, and the part of the server, request, get, and post. So you can see there, we have a perfect output of the full arrays that are usually set by PHP. So another implementation, I did this game, leprechaun.outlook.com, and I put another variation that is /bot. And instead of play, you have to develop a specific code in PHP to play. This is working Elixir. This is the code is in GitHub if you want to check it. The base of how it's working is you have to go to the code tab and then write the specific code. There is a specific code that is working now to play the game, and then pressing run. That code is sent to the server, is compiled to be running, and then it's playing to the game. And you can see how it's playing the bot to the game. And well, the project is in Bragful PHP. We use Travis CM CI to check every commit that is done. The coverage of the code is 87%. It's low still, but it's not bad. It's published in Hex. The version now is 0.2.7. You can see there how it's working in Travis. It's published for most of the OTP versions. There are some of them that were a bit buggy, so I kept them out, like 20.3, because they have issues in the math library. And what is doing in Travis is the compilation, cross-reference to be sure that there is no functions code that are not existing. Running the test, these days are 516 tests. The coverage is 87%, and dialyzer through 0 warnings. So it's intended that the code is good enough. It's published in X, as you can see there. And well, if you want to help us help you, if you want to use it, please use it. If you have one project or something like that, or one twin project, is okay. Report backs in GitHub. We have issues part reporting, and you can add more functions in the ePHP modules or create your own extensions. You can join us in Jitter, that is the link in the GitHub, and give us a start in GitHub, of course. So, thank you. I have not a mix, but if you have any question, I can give you the mix. Any questions? No. That's all. Thank you.
What does the room say?
What is it?
What's better?
Can you hear me?
Can you hear
No.
me?
The other one.
Can't hear me, just raise your hand.
Was it better before?
Yeah.
Yeah.
I think they're all together.
Okay, I have it on here.
is here with us, representing us this caliber robust intelligent systems. So,
Thank you.
you guys.
So thank you very much for having me here today under strange circumstances. I used to only have to worry about viruses in my computer. So I'd like to talk to you today about tactics and strategies for scalable, robust intelligence systems. And I even have a little feature here for Joe Armstrong, about a feature that he know and love very well, namely the Become command, right? How you can use that to upgrade actors in place in the new version. And so first I'll talk about the tactical stuff, and then I'll talk about the larger strategic situation in which we find ourselves. And the big strategic situation is we have this big challenge about what to make about our relationship with China. And so here the big issues are national security, employment, and civil liberties. Of course, it's a big national security problem for the national security services, because if they fall behind, then they don't do so well. And in terms of deterring others from attacking us. And employment, if the what's going to happen, I project on Stanford and other universities, I don't speak for Stanford, but a bunch of us are working on something, is what's happening, I think, and I'm seeing a slide here, just a second. Okay, let's see what we can do here. So we're at the verge of transformation, which we go to universal intelligence systems. And I'm going to explain a little bit about how that is projected to happen. And that means that if we have to rely on China for this technology, the employment will be there as opposed to being elsewhere in the rest of the world. And also, if we have to rely on China on this technology for universal intelligence systems, then it's unlikely they're going to provide us with very good technology for our civil liberties. That's maybe the understatement of the year, right? So these are our challenges in terms of how to respond. In other words, are we going to mount a national project? But I think it should be an international project. That we should get our allies together from the United Kingdom, from Germany, from France, from Japan, from Singapore, from South Korea, from Australia, to join together with us to create a version of these universal intelligence systems that we can live with and still have civilian liberties. So Liftoff is the proposed name of the project, and it's a strategic project featuring education and science, and it's to build a specific technology stack that I will describe to provide universal secure intelligence systems, and as JFK would say, to be done in Mysticon. And so it's very much analogous to Project Apollo, where again, we were faced with a strategic challenge, and they did Project Apollo. And the achievement of Project Apollo was not to plant the flag on the moon. The achievement of Project Apollo was to build a technology stack to get there. And that really was one of the main things that booted up Silicon Valley here, San Francisco and south of us, because it was the requirements of doing that project meant that we had to develop huge command and control systems, technology for that, the software, and we had to develop microprocessors that could be carried from the moon and back and not weigh as much as a refrigerator. So it was that developing that technology stack and that technology infrastructure was the real achievement of Project Apollo. And it took the decade, and this one will also stretch on through the decade. So that's the liftoff. Oh, I see. Okay, so I'm looking at there. You're looking at, okay, I was looking at the wrong screen. They actually give me both of them, the next one. So I was looking at liftoff, right? You were seeing the other one before, so now let me advance here. And the driving force is typically, in these things, is typically hardware. And what that means is that these electronic glasses are finally going to become real. We've had sort of the homebrew computer club version of them before, but now they're really going to take over and basically be used for just about everything at the end of the decade. It's projected by the end of the decade, there will be as many hologlasses in active use as there currently are cell phones, because this business of me talking to you like this is a terrible way to dehuman factors, really. So instead, it'll be done, everything that you currently do, you can do using your phone, your smartphone, you'll be able to do using these hologlasses. And the exact way it's going to be done is, of course, a proprietary secret of these companies, but we need to know something about it. And one of the things is that in addition to the hologlasses, that everybody will also have a case. The case will have the big battery. The case will have the 5G communications, so that the glasses only have to talk to the case. And you won't have to wear the glasses all the time, just like you don't have to have your phone in front of your face all the time, okay? You can take the glasses and put them in the case, and they'll recharge in the case. So this is going to be a great move. They're going to be used for driving. They'll tell you when there's a stoplight that you don't see and you're about to rush through, they'll say, hey, wait a moment. The traffic sign, the traffic light will light up. It'll help you, it'll help me when I'm about to go down these stairs, you know, it'll see I think there's stairs on both sides here, but there's not. There's a cliff over here. So if I start wandering over here, the glasses all of a sudden will say, wait a minute. And they'll be used in pain management and dementia management. So it's projected they'll be used for just about everything. Many things for which with the smartphones you can't use them for. It's just not the right form factor to be holding this thing in front of your face. In fact, in California, it's illegal for me to drive holding this thing in front of my face. But we will be able to use the glasses. So what that means is we need an underlying technology, right? And so there's a theory called actors, which is basically a way to formalize digital computation, all digital computation, up to a unique isomorphism. And these actors, from the theoretical curiosity, can actually prove that they're more powerful than Turing machines, and they're more powerful than the pure lambda calculus, because they have concurrency, something that we know and love in the Erlang community, right? And that is the secret ingredient. The deal with Turing and Church is they thought they were supposed to formalize the computation that could be done by a single person using as much paper and pencil and ink as they needed. And they didn't think about the fact that you can do computations even with two people that you can't do with just one person. So that is the secret ingredient in this technology that we're developing, is communication. And it's not just communication between two, it's communication amongst billions of actors, where we're going by the end of this decade. So the way that's can be conceived is in terms of actor systems, not just individual actors. And so you have communications coming in from the outside, going to the outside, and you have certain more primordial actors, okay, that are born when this actor system is born. And on the basis of this, we can prove properties of these systems using induction. Now, it's not the kind of induction you're used to for the integers, right? Where if P is true for 0, and if P is true for J, then P is true for J plus 1. If you can prove those two things, then P is true for all natural numbers. So instead, it's invent induction, and it says, for those of you who don't, who are copacetic with upside down A's and backward E's, what it says is that for every predicate, okay, on events for the system S, if X is a primordial, then P must be true for the creation event of that actor. If you have an event from the outside, then P has to be true of that event. And furthermore, for every event, if E1 immediately follows from E, and then if P of E is true, then P of E1 is true. This is the induction. So if P is true of this event, then it's true of the immediately following event, then it holds for all events. And that is the fundamental principle for proving properties of these concurrent systems. You can prove anything this way if you have a little bit of education to help you out. There should be a little tutorial on that. And from that, you can prove the classic kinds of things that were developed by Turing and Hoare, and that's called actor behavior induction. Now, this is just taking, instead of an actor system, we just have an individual actor. And if you just have an individual actor and a predicate on behaviors, then if P is true of the initial behavior of the actor, and there's a bad indentation here on this slide, and I can't fix it now. And for every event that the actor receives, P is true when on the behavior when it receives the event, then P is true after it has processed that communication. So that's how you can specialize this, because then it becomes a theorem of the more general principle for systems. So this is one way if you just have to prove something about an individual actor, sometimes you can get away with just doing this. So the hardware is shifting rapidly, and so by the end of the decade, as JFK would say, we're going to have millions of actor cores, okay, inside these little cases for our phones, and with quadrillions of actors. And the trick is going vertical. You'll build little vertical stacks on top of these chips. And that's the way we're going to get the additional capacity, because we've run out of scaling once we reach 3 nanometers in terms of the current technology, silicon technology that is used for chips. You're only a few atoms thick, so you can't get any more components on that way. So we'll go vertically, and already we go vertically with DRAM, with high bandwidth memory. We have little stacks of chips on these systems now. We have to do the same things for the processors. So now, since we've got lots of coders in the room here, I'd like to talk about a little programming problem and then explain how it relates to Erlang and the other systems that are run here at CodeSig. And the problem I'm interested in talking about is the problem of booting over the internet. So we want to boot up a processor over the internet, as soon as it's got a controller over there, and we want to boot up a new image. Could I get a little bottle of water or something, please? Thank you. So here we go, booting up over the internet. Oops. Booting up over the internet, yes. So I'll have a controller, and the controller has an interface in which you can get in 3 kinds of messages. You get a boot message, a shutdown message, and an upgrade message. So when you get a boot message in, okay, you'll have an item, which is the image to be booted. It's got to be signed, and will produce a termination report after it has run. And when you shut down, it'll shut down the running system and return void. Thank you very And then when we get an upgrade message, we'll be given a new controller, okay, to replace us, which also must be signed. So that's the interface that we need to implement here. So what's tricky about this interface is you get the boot message in and you have to return a termination report, right? But you also have to somehow allow a shutdown message to come in while you're doing the boot, so that you can be shut down, so that you can then get an upgrade or another boot message. So this is the kind of thing that, you know, really difficult to do in a language like Java, for example. Because what we need to do is we need to have a hole in the region of mutual exclusion. It's because we're going to get the boot message in, okay, and then we will take our region of mutual exclusion so we can update the version number. And then we have to release our region of mutual exclusion, okay, so we can let the shutdown request come in. And then we have to take back the region of mutual exclusion so that we record that the controller is no longer running. So here is what it looks like in terms of booting over the internet. And I've got this wonderful situation here where the thing is so small that I can't see it here. I double click on this, could I make it big so I can read it too? Okay, this is challenging. How am I going to do this? I can't read it. And what I really need is, if we get the portable microphone, let's switch to that. Come on a second. Oh, wait here. Do you have a portable microphone over there someplace? We have a laser pointer, I can find mine here. I'll just point. There we go, this will work fine. Okay, so we have a processor controller that has a public key that implements the controller. The current version is initially 1, and we're going to keep track of the thing that's running in this hole in our region of mutual exclusion. So here we have our 3 messages. We've got a boot message we can take, a shutdown message, and an upgrade message. So if we get a boot message, we first have to check to see if the system's already running. So we do, it is running cases. If it is already running, we have to check the signature on the image. Then we have to check about whether the system we're booting is a more recent version of the system we're running now. If it is, then we're going to have to update that to the new version. Because what we want to do is we're afraid of replay attacks against it. Somebody will give us an old version of the system to boot, and we don't want that. So if the version check succeeds, then we update the current version of this assignment command, and then we run the code running through the hole in the region of mutual exclusion. Okay. So that's what's happening here in terms of the boot. When you get the shutdown, you check to see if you're running. If you're not running, then you throw a not running exception. Otherwise, you cancel the running system and you're done. When you get an upgrade, and here's the part that Joe Armstrong really liked very, very much. You check to make sure that the new version is signed correctly. And if it is, you become the new version, otherwise you throw a bad signature exception. So the tricky part here is this code.run, which is run in a hole in the region of mutual exclusion. And so this language here, which is called ActorScript, is designed for doing that because in our intelligence systems, you have to do this all the time. You're always managing a region of mutual, manage some local state. To protect that, you need a region of mutual exclusion. And in constantly entering and leaving this region of mutual exclusion. That's the kind of thing that these intelligence systems do all the time. They have to be able to do so conspicuously and efficiently. So now let's see what that would look like in a language that uses one way of message passing on airline process. So here we have it, the very same program, very same messages. Only now we need to bundle things up together, okay? Because when the request comes in, it's also going to come in with customer C. Think of C as a PID for another airline process, right? That we're going to send the response to. And the other thing is that when we do this business of running the code in a region of mutual exclusion, what you do is you assign the identifier running basically to the PID, the process ID of where you're running the code, so you can later cancel it when you need to cancel it. And apart from that, it's pretty much the same, except that you always have to package things up. Because you see, when the book request came in, and all this stuff came in with the request, we also had to package it up. This is one-way message passing. We also had to bind the customer, bind the process that sends the work to get the response from this. So that's kind of the relationship between the airline doing business and the ordinary kind of request response way doing business. Because an ordinary request response, you see, you send in a request with a request message to the customer, that's a one-way message. And then when you want to get the response back, you then send the customer either a return message or a return message or a true message. If you want to say something wrong. So that's basically what goes on there between these airline languages, which do one-way message passing, and the more traditional languages where everything's based on two-way message passing. So why is that so important to us? What does this deal? Well, what we need to get to is we're going to use these actors to make these massive ontologies. And the massive ontologies are made up of little bitty elements, billions of them, that are sending messages back and forth. And in this ontology, we're going to put all the information. Basically, you put all your personal information in there so that we can organize it. And once we've done that, we'd like to get out of the trap we're in now, where I have an iPhone that's got 200 apps on it, and the apps don't talk to each other, really, except maybe indirectly from some data center. But for the most part, they don't talk to each other. And we would like to get out of that trap. And so what that means is that we need a system that can perform inference on all of this information. And there's a lot of it. We need a massive inference for loss ontology as the fundamental basis for these intelligence systems. And this ontology will be, say, a terabyte big to start with, right? A small one. And within that, a huge amount of concurrency will take place of the kind of message passing that I just showed you. All the little actors in there, there'll be actors for propositions, there'll be actors for procedures, plans, and strategies. There'll be actors for trainers, classifiers, synthesizers, and verifiers. There'll be classers for browsers and editors. You have to keep provenance and narratives and histories. There'll be auditors, evaluators, and supervisors. There'll be goals, recommendations, and policies. All this stuff has to work together concurrently. And we can't use classical mathematical logic because if we had a single inconsistency, the whole thing would blow up. So you have to use inference robustness. And that's basically been worked out by some theoreticians and help them do this. And that is the new paradigm for how we're going to do this. And this is different from a relational database because, point one, the data is not arranged in rectangular tables. And point two, relational databases don't deal well with the inconsistent information at all. It is not for SQL, it's not prepared to deal with that. So you might ask, where does machine learning come into this? Right. Then we have a classifiers, right? It's right here, this tiny little piece here. The classifiers is where the machine learning does. And that also goes into the data ontology. So machine learning as it currently constitutes only the slightest part of Project Liftoff. You need to use the classifiers. But the classifiers are also going to need verifiers because they're not very reliable. And so that's why we have such a big job here. We can't just build on the classifiers. The classifiers won't do it for the task that we have at hand. Okay. So, the other challenge we have, you see, in doing this, so far everything could just be done, in data centers. But this task cannot be done in data centers for two reasons. One is if you're running the intelligent system for your classes, there's not enough computational power and there's not enough bandwidth for the data centers to do the whole job. Most of the job will have to be done by the glasses holder that you have, which has the big battery, the big communications, the big storage, and the processing. So most of it has to be done locally, and it has to be an intelligent system. So now comes the question about civil liberties. If we can do this on our own equipment and keep our most precious, secure information secure on our own equipment in a Citadel, if we each have a Citadel, then there'll be some pieces of some kinds of information for which is secure to you, right? That unless you give it to somebody, they don't have it. So that is the challenge. Can we build a system of citadels which have increased responsiveness and reliability, and also in personal information security? So for example, a citadel would be your glasses with its case, your home router, your home TV, the other stuff in your home, you arrange in a citadel. So here's a picture of a citadel where we have the various pieces of it. We have the home router, your car, your display, your glasses, etc. And that's just for you. And that would be much more secure than the potential having civil liberties of doing that. Now, there are lots of people who have come across this idea of the Citadel, right? The challenge now is to implement it together with an ontology. So you have an ontology here, and it has to be distributed among these devices. So you don't want to lose your Citadel just because you lose your smartphone, right? So it's distributed among them. And then with your own private key, you can back this information up in these data sets. But since you've encrypted it with your own private key, it's still secure to you. So that's all well and good. But it won't happen in this world unless there's a business model. So what business model works in this world? Advertising. But now it can be personalized advertising, right? Just for you. So it doesn't have to interrupt you all the time. But there actually is a legitimate business model in connecting merchants with customers. That is a legitimate business model. But we'd like to do it without mass surveillance, where they get everything, right? And we'd like to do it in a nice way, so it really is helpful to both the merchant and the person and the potential customer. And that's a possible way to do it. And then that can finance this thing. Then you have a business model that can be made to work. So, but it's not just the citizens that are interested in the Citadel.